Assalamu alaikum students. Today we will study the program or MATLAB code of the Jacobi's method. So first of all, you have to take the review for the Jacobi's method. Jacobi's method is an iterative method to solve the system of linear equations, and what you have and what should be the output should be the values of the unknowns. That means x1, x2, x3 in the 3 cross 3 system, for example. And what you have is the coefficient matrix A, and then constant vector B, and also the initial guess and number of iterations and tolerance and all that. So let us first declare the function. So function is equal to x is equal to Jacobi, name it Jacobi, and A comma B comma initialize, let initialized guessed be P or X naught. You can use any variable for that. So that is initialization, and then your vector A. So A I am writing just to justify this as 9 space, write in the matrix 9 space 1 space 1, and then 2 space 10 space 3. Okay, and also 3 space 4 space 11. So this is the coefficient matrix, and now you have to write the column vector, sorry, constant vector. Constant vector is 10. That is a column because it contains 3 rows and 1 column, so is equal to 0. So this is all about the given inputs, and also the P. P is because x1, x2, x3 is 0, 0, 0 initialization, so that it is equal to 0, 0 and 0. Okay, so number of iterations is left, so n is number of iterations, let it be 15, almost 15 to 20, you can use it anywhere. And yes, one more thing is L is equal to, let it be length of A. Length will judge the highest dimension of this B, because it will takes on the value, it will take on the value for this. So length of B, and that's it. Now you have to start the loop. Now for k is equal to 1 to n number of iterations. If you have n length of this number of iterations, you have to run it 15 times, and that you have to use the nested loop, and for that you have to use, for j is equal to 1 to l. L means length. That means if it is if it is b 3 cross 1, for instance, then j should be run 3 times, 1 to 3. Okay, simple one step is required in this, and that is x of j, a particular unknown. Okay, b of j, let me do this step by step. B of j minus a. Okay, now you are changing the columns. Now in a specific row, your columns are shifting towards the left hand side, because you have to write x1 first equation in terms of x1, second equation in terms of x2, and third equation in terms of x3. So all you need is these 3 unknowns, and that all row operations. So iterative method is all about that. J comma, now your j is, you have to exclude j from it. So 1 to j minus 1 comma j plus 1, you have to split that in double, because you need to exclude that aj in the row, in that column, basically in that column, j plus 1 to l. Okay, interesting. Multiply by that initialization value of x2, x3 if it is x1. So multiply by b of same column. Okay, and same column is 1 to j minus 1 comma j plus 1 to l, and brackets divided by a jj, I or jj, you can use any variable, and final step is p is equal to the transpose of that vector, x bar transpose of that vector, and that loop is end, and then x is equal to x transpose, just to make it a column vector, and that's it. Okay, so if I run this, okay, save it as Jacobi. Okay class, I got the mistake. I forgot to mention this in this, and now my parentheses are balanced. So if I use this, execute this, then it will display the answer, and that is 1 to 1. In which iteration? In almost 15 iterations it will display. If I change it, if I want 12 iterations, I want to see that whether it is, yes, it is changing here. So after 12, and if I would say 13 iteration, what will be the result? Yes, 13 iteration, I starts to having a repeated root. So now let me explain this step. Xj means x1 is equal to b1 minus a. B1 means x2 and x3 is shifted, so x3 is, this is the initialization, and b1 minus a1 2 1 2. That means that column is not 1 here, row is 1, but columns are not 1 here, because that a11 is divided here, so you have to exclude that j. In order to exclude that, you have to split this column from 1 to j minus 1 and j plus 1 to l. So that means a12 into x2. So that is x2, basically p initialized variable, minus a13. a13 into p 3, that means x3, divided by a11. And also second step is that x2 is equal to b2 minus a 2 1 to 1 into x1 minus a23 into x3 divided by a22, and similarly x3 is equal to b3 minus a3 1 into x1 minus a3 2 into x2 divided by a33. So this is all about the Jacobi's method. It's a very simple method, and I hope that you understood this all theme.